So B-CRATOS, as you all know, has been an ambitious plan, an ambitious project that has been targeting brain-computer interface in its true sense. So what is in its true sense? It has to do with the full duplex communication between the brain stage or the head stage and a peripheral device. In our case, it's a mechatronic hand. So the challenge in developing this is to create a system that is seamlessly integrated between different protocols and different versions of the hardware, which has inherent differences between the operational location on the body. So we have hardware systems that are partially implanted, wearable, superficially placed, and also integrated to the extremity, such as the biorobotic hand. So they all have their own challenges. One of the important challenges that we had to encounter was to unify the protocols to create a good data fusion so that you have a seamless operation with respect to the transmission of data from the brain stage to the hand so that the hand can operate. Also to get information which is proprioceptive from the tactile sensors inlaid in the hand, the palm of the robotic hand, back to the brain through the fat channel so that you could stimulate the somatosensory cortex, thus establishing a full duplex communication. Another challenge is related to demonstration of the whole concept. The demonstration has to be done in a living model. So here in our project, the living model is a non-human primate, a monkey. So the monkey has to be trained in advance so that it could take care of specific tasks on cues, on inputs, and the respond to specific orders. And this has to do with respect to the information that has been produced by monkey in its brain, which is wirelessly transmitted through the fan in the monkey's body and operate the hand accordingly. When you talk about the body, the morphology of the monkey is not a heavy animal. It weighs as small as 5 kilograms or 6 kilograms max. And presumably the fat under the skin of the monkey's body is very less. So it's inherently hostile environment for the fat IBC to operate. So it's not the best subject to try, but it's a very good subject to try in terms of the reliability and the robustness of the communication. So we have succeeded in transmitting enough amount of data through the monkey's fat, which is useful for high bandwidth communication between the brain and the robotic hand. So we encountered challenges, but we have overcome it nicely, and we have demonstrated that you could send real-time data through the monkey's fat, and this implies that it could be used with ease in human body, where human fat distribution is much better than a non-human primate. So when it comes to the hand itself, so there is an aspect of seamless integration of proprioceptive sensors, which are tactile sensors, onto the fingers and in the inlay of the palm, so that you could get information regarding proprioceptive intents, where the hand is operating on an external object, and then that could be translated into stimulation intents in the head stage. So this part is done by Lynx Foundation in Italy, in Turin. So we were able to do a run in which the stimulation information has been deciphered and used for stimulation in the head stage. So we also implemented the batteryless backscatter system. So the power level that it uses, the whole circuit complexity without developing any heat constraints or concerns has been achieved also in this project. So thus we were able to establish a full duplex system of a higher bandwidth and a higher speed, more than 64 megabits per second, in order to achieve the overall concept of B-CRATOS, which is the brain-machine interface. In between the project, we also had an issue with respect to the expiration of animal trial license. So we have applied for an extension of the animal trial, which has not been approved within the stipulated time of the project. For that reason, we have emulated an alternate, a parallel setup, which reflects all those nuances and considerations of non-human primate trial. And we have established a protocol to try the complete system within B-CRATOS framework in DPZ in an environment similar to non-human primate, and we have done a full-fledged run of the B-CRATOS data flow. And then we have been successful in succeeding. We have been successful in getting the data which is pertinent to the success of B-CRATOS project. Thank you.